Hi, Assalamualaikum and a very good morning. So now we are still in chapter 4, chemical bonding. And now we're going to focus on the subtopic of 4.1, the Lewis structure, part 3a. So in this video, we're going to look into the determination of the formal charge and the most possible Lewis structure, which is in the part 3a and 3b. But now we're going to focus on the part 3a first because it contains two things and they are interrelated to one another. For the learning outcome of G, we're going to look about that in part 4. Meanwhile, for the learning outcome of H, which going to be covered in part 5. So without any further ado, let us start with part 3a first. So drawing of the Lewis structure. So for the drawing of Lewis structure, we're going to have 5 important steps here. So for the step number 1, we need to determine the central atom and we have to calculate the total number of the valence electron. And for the central atom, the most often one is the more electropositive one. It's going to be the central atom. Meanwhile, for the hydrogen, it will never be a central atom. It will always be the terminal atom. Okay, so the central atom is the atom that is in the middle. Meanwhile, the atom that are at the side, which is B here, is known as the terminal atom. Okay. Meanwhile, the atom level at the center is known as the central atom. Okay, and for the central atom, it will never be a hydrogen and it needs to be the most electropositive among the atoms in the molecule. And in order to determine the total number of valence electron, we need to deduce it from the group to which the element belongs. When the molecule have a negative charge, then we need to add the total number of valence electron by 1. However, when the molecule have a positive charge, something like this, then we have to minus 1 for the total number of the valence electron. And then once we're done with step number 1, we need to proceed to step number 2, where we need to draw a single bond between the central atom and each of the surrounding terminal atom. And after we've done that, we need to calculate the non-bonding electron. Okay, so let's say A is our central atom, and then we're going to have the terminal atom B at the side. And after we finish drawing that, we need to calculate the non-bonding electron. And the non-bonding electron that we have calculated is then used to complete the octet of the terminal atom, and the remaining electron will be placed at the central atom. Last but not least, we need to form double or triple bond if the octet rule is not satisfied. To understand more about this step here, let us look into the example. So, for the example of molecule number 1 is we have the methane here, so which is the structure of CH4. So first thing first, we need to determine the central atom and count the total number of valence electron. So in this case, the carbon gonna be the central atom because hydrogen will never be the central atom. So we know that the central atom gonna be the carbon, and in order to determine the total number of valence electron, we need to look at the groups at which the element belong. So for carbon, it stays in group 14, right? So it's gonna have 4 electrons. Meanwhile, for hydrogen, it's going to have 4 hydrogen here, which means that 4 hydrogen multiplied by 1 electron because hydrogen is in group 1. So we're going to get 4 electrons as well. So the total number of electrons that we have in the CH4 molecule is going to be 8. Okay, so since we have 8 valence electron, now we need to draw the single bond between the central atom, which is carbon, and then we have 4 valence electron of hydrogen. So 1, 2, 3, and 4. And our terminal atom going to be hydrogen, 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 and hydrogen. And as what you know, the single bond here representing 2 electron. So 2 electron, 2 electron, 2 electron, and then 2 electron here. So the total number of electrons that we have used up in order to make the bonding going to be 8. So we need to minus by 8. And hence we have 0 electron left. Okay, so when we draw the molecule, we're going to get the CH4 to be something like this, where all the bonding has been used, all the electron has been used in order to make the bond big. And then because since we have no electron left, so we doesn't have the next step, number 3 till number 5. So we know that the Lewis structure of CH4 going to be looking something like this. Now let us look into the next example, which is the ammonia here. So similarly, we need to determine the central atom. Okay, so the central atom going to be nitrogen because hydrogen cannot be the central atom. So we can say that the central atom going to be nitrogen. And now we need to count the total number of valence electron. So the total number of the number of valence electron of nitrogen, because it is in group 15, so you know that nitrogen going to have 5 electrons. Meanwhile, hydrogen, we have 3 times 1. Okay, so the total number of valence electron that we're going to have is 8 valence electron. So now we're going to make a single bond in between the central atom with the terminal atom. So we have nitrogen in the center, and then we have hydrogen, hydrogen, and hydrogen. Okay, so you know that we have made a bonding in between the central atom with the terminal atom. So we have used up 2 electron here, 2 electron here, and then 2 electron here, because one single bond representing 2 electron. Okay, so minus 6. So we have valence of 2 electron. Okay, and then these 2 electron here will be used in order to complete the octet of the terminal atom. Okay, but as what you can see here, because our terminal atom is hydrogen, hydrogen, and hydrogen, so hydrogen is already stable because hydrogen has received 2 electron, which is a duplet electron arrangement. Same goes to here, and then same goes to here. Hydrogen get 2 electron, hydrogen get 2 electron. So they are stable. So we don't have to complete the octet of the terminal atom. So we can skip this step. However, the balance of 2 electron here can be placed at the central atom, which is at the nitrogen. So what we're going to do is we're going to place the 2 electron, 1 and 2, at the central atom. So lastly, we're going to get to be something like this. Okay, and if you were to count the number of electrons surrounding the nitrogen, we're going to get 2, 4, 6, and 8. So the central atom here going to be octet, and they are stable. Okay, so we can skip the step number 5 as well. Now let us move on to the next example here, which is the H2O, which is our water. So similarly, we need to determine our central atom. So our central atom here going to be oxygen, because hydrogen can never be the central atom. And now we're going to find the total number of valence electron. So oxygen is in group 16, so it has 6 valence electron. And then we have 2 hydrogen, so we're going to be 2 times 1, 2. And then the total number of valence electron that we're going to have is 8 valence electron. And then the oxygen here will need to be bonded with 2 terminal atom, which is hydrogen and hydrogen. Okay, so we have used up 2 and 2 here, which is minus 4. So we're going to get the balance of 4 electron here. So the shape that we're going to get is HOH here. Okay, so the balance of 4 electron, we're supposed to fill in their terminal atom. But similarly as before, the terminal atom here has already stable because the hydrogen here is duplet. It already received 2 electron and then 2 electron. So we can skip the step number 3. So the balance of 4 electron here will be placed at the central atom, which is our oxygen here. Okay, so what we're going to do is we're going to put 1, 2, 3, 4 at the central atom. So we have used up all the electron that we have. So lastly, we're going to get our Lewis structure here to be HOH with a 2 lone pairs here. And as what you can see, the oxygen here will have 8 valence electron, which is 2 electron here, 2 electron here, 2 electron here, and 2 electron here. So it's going to have 8 valence electron surrounding the oxygen here. So it is a octet electronic arrangement. Now let us look into another example, which is regarding the carbon dioxide. So carbon dioxide, we need to follow the similar step as before, which is number 1 to number 5. So for this case, between carbon and oxygen, which one gonna be the central atom? Yes, it need to be the most electropositive. So between carbon and oxygen, carbon is more electropositive. Okay, because you have learned in chapter 3 that across a period, the electronegativity increases. So you know that carbon will be the more electropositive in comparison to oxygen. And then we need to count the total number of valence electron. So we have carbon, which is in group 4, and then oxygen, which is in group 16. So it has 6 valence electron, and then it has 2, so we multiply by 2. So the total number of oxygen, the total number of valence electron that we have is 4 plus 12 is going to be 16 altogether. And then the 16 valence electron here will be used in order to make a bonding. So we know that carbon going to be at the center, and then it's going to have oxygen on this side and oxygen on the other side. So we have used up 4 electrons to make the bonding in between the central atom with the terminal atom. So we have 12 electron valence. Okay, and the 12 electron here will be used in order to complete the octet of the terminal atom. So as what you can see here, our oxygen has only 2 electrons. So they are lacking 6 electrons because for oxygen to be octet, it need to have 8 electrons. So they need 6 electrons more on the right hand side as well as on the left hand side. Okay, so what we're going to do is that the 12 electron here will be used in order to put 6 electron on the right hand side and then to the left hand side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have used up all the electron that we have. So it's going to be something like this. Okay, and then for the step number 4, place any remaining electron for the central atom. So since we don't have any, so we don't have to place any electron on the center. And now you're going to check the step number 5. So we need to form double or triple bond if the octet rule is not satisfied. So as what you can see here, the carbon has only 4 electrons because it has 2 here and then it has 2 here. So it needs another 4. So this can happen when this electron here transferred to there, and then this electron here transferred to here, as if you're going to form a triple bond. Sorry, 1, 2, 3, oxygen, dot here, and then this one will stay like normal. Okay, so dua elektron tadi akan membentuk lagi satu bonding, dua elektron di sini akan lagi satu membentuk lagi satu bonding. So dari single bond akan menjadi triple bond. Okay, so what gonna happen here is that you're gonna need to make the carbon to be octet. So you're gonna have 2, 4, 6, 8. So it become octet now. Okay, because it have 8 electron at the central. Same goes to the terminal, 2, 4, 6, 8, 2, 4, 6, 8. Okay, so this is the possibility number 1. Okay, okay, so you can do that on the left hand side, or you can also do that on the right hand side. Okay, so you can do it to be something like this. If you don't want to use the electron on the left hand side, you can also bring this to here and then to here. But then it is the same thing because the left hand side and the right hand side is still the same. Okay, so you can choose either one of those. Okay, or the other possibility that you can make is you can bring one lone pair to this side in order to make a double bond. So it's going to be here and then here, and then 2 electron here on the right hand side in order to make another bond, the extra bond here. So it's going to become like this and like this. So what you're going to get is you're going to get double bond on the left hand side as well as on the right hand side. Okay, and the lone pair electron you can copy back again. So it doesn't matter, you can choose the lone pair from this side, or you can also choose the lone pair on this side. So it doesn't matter because it's basically the same wherever lone pairs that you take. So these are the two possibilities that can happen. Alright, now let us look into the next example, which is the NO2 plus. So similarly for NO2 plus, we need to determine the central atom. So we have our nitrogen and then we have our oxygen here. So nitrogen is in group 15 and our oxygen is in group 16. So across a period, the electronegativity increases. So this one is more electronegative. And hence, this one is more electropositive. So the nitrogen going to be the central atom. And as usual, we need to count the total number of valence electron. So nitrogen is in group 15, so it has 5 valence electron, 5 here. And then we have 2 oxygen. So 2 times 6, we're going to get 12. And then we have the charge here, which is plus 1. So when we have a charge of plus 1, it means that we don't need electron. So it's going to be minus 1. Okay, so charge of plus 1, but the electron going to be minus 1. So the total number of valence electron that we're going to have is 16 altogether. Okay, and then this valence electron here will be used in order to make a bonding between the central atom with the terminal atom. So since we got two terminal atom, which is oxygen and oxygen, so we have used up 2 and 2 here. So we're going to minus with minus 4. So lastly, we're going to get the total number of valence electron to be 12 electron. Okay, and then the 12 electron here will be used in order to make the octet for the terminal atom. Okay, so as usual, we're going to put 6 electron on the right hand side and then the 6 electron on the left hand side in order to make the oxygen octet. Okay, so 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So we have used up all the electrons that we have. Okay, so lastly, we're going to get to be NO with 3 lone pairs and then NO with 3 lone pairs here. And then now, we don't have any remaining electron in order to fit in the central atom. So what we're going to do here, because this nitrogen here is not octet yet. Okay, so what we can do is we can bring the lone pair, you can choose any, in order to bring it to the middle. Okay, so you can bring one to here and bring the other one to here. So that you're going to get N, O, N, O, and then you copy back the lone pair that has not been used. So for example, like this. Okay, so the 2 lone pairs here is used to make up the bonding pairs, and then 2 electrons here will be used in order to make another bonding pairs. So the nitrogen here going to have 2, 4, 6, 8. So it become octet already. Okay, so similarly to the terminal atom, 2, 4, 6, 8, and then here 2, 4, 6, 8. So all octet. Or you can make another choice where you can bring 2 electrons here to make a single bond, another single bond, and then you can also bring another electron from here so that it's going to form a triple bond on one side, and this one is left unaffected. Okay, so you have 2 choices. So the choice number 1, A or B, like this. Okay, because at last the nitrogen here will also get 8 electron And then here, oxygen here will still add electron, and the oxygen here will also have 8 electron. 2, 4, 6, and 8. Okay, similarly to here. And of course, you can also do it on the right hand side. But at the end, it's still the same meaning. Okay, so basically, you can choose it to be like this, but basically they are identical. It's just the position that are different. So basically A or B. Okay, so we have two options here, which is the option A, which is number 1, or option B, which is the triple bond, either on the left hand side or on the right hand side. Salah satu, because molecule tersebut adalah sama. And because we having a positive charge, so all of our structure here need to be bracketed with plus sign. Same goes to here. Okay, so this is how we draw the Lewis structure of an atom. So I think that's all for today's video. See you again some other time. Bye.